Long gone are the good old days when man and womankind could enjoy themselves sitting around a campfire, chatting, singing, dancing and sharpening sticks, only concerned about when the next meal was going to walk past. Today, us primitives live in the information age where data matters. From satellites looking down from above, cameras sighted at every street corner, electronic surveillance monitoring our every mouse click, thought and action, allowing governments, big businesses and other crims to watch, track, pervert and record our every move. Each day, huge and growing amounts of data is collected and processed into information.
Information. You won't get it.
It's unerring to realise how much more is known by others about you than you even know about yourself. Well, so what, I say? Let's just go with the flow and do some monitoring and recording of our own. We are able to deploy high technology with its plummeting prices and join together to amass data in our own citizen science projects. Here is one of many called Telraam, and it allows us to place small video cameras on a street or in a window and observe and record the passing traffic. It uses artificial intelligence to identify pedestrians, cyclists, cars, vans, lorries, and record them, and even their speed and direction. Of course, when we say identify, we mean in a friendly, anonymous and helpful manner. It's an open source project, as all of the best are, which means that you can freely download or assemble and modify all of the elements of the project for yourself. Nothing is hidden. Sign up and join into the growing band of similarly minded individuals and organisations amassing data together. Contribute and benefit from the information revealed. Should you really want to delve down into the inner workings and discover how the technology works, then you are free to do so. We hope it will be of great benefit to you, help you with your hobby and career, and perhaps in the future you can return and demonstrate how it should have really been designed. For the rest of us, we'll be plain users of the system, employing it as part of wider projects and interests. This is what this video is all about, a simple step-by-step introduction and explanation of how to get started. Very little previous experience is assumed. We are now going to explain how your view of your street can be included in a global insight of traffic management and later on also pollution. The Telraam system consists of two main elements. Your camera monitoring device connected via the internet to the Telraam cloud. Your street view is analysed and passed back to Telraam to be processed and included in the global map for all to view. So, what are these components? Well, we first need a street. We then need a camera. The camera requires some intelligence and a method of communicating and obviously a power source. Communications is via the internet to and from Telraam, which for our purposes is in the cloud. To prepare Telraam for our connection, we need to register an account and enter the particular details of our device, or later on more devices. In return, Telraam assembles and stores our data for distribution and also provides a system update back to our device in the same way as modern phones are constantly reconfigured to the latest specification. Our camera is typically designed specifically to connect to the Raspberry Pi. The Pi is a low-cost credit card-sized computer originally designed for use in education, but it's exploded into the gold standard of single-board computers with sales of over 40 million as of May 2021. It includes its own Wi-Fi connection, used as a communications link, with power being supplied by a mobile phone charger. In normal operation, it would also require a screen, keyboard and a mouse to act as a standard computer. But here, these can be dispensed with as the system is going to operate automatically in what is referred to as a headless configuration, and we will return to this later. The final key component is the operating system and the program that turns the standard Pi into a particular version able to configure the camera and converse with Telraam. This is supplied on a micro SD card. Once plugged in and switched on, it jumps into action immediately, as we will see. Note that all these components may be purchased as a kit via the Telraam site, but the purpose of this video is to describe how this may be achieved directly in several simple steps. Step 1. Acquire a Raspberry Pi, camera, power supply and micro SD card. The current system does not require huge amounts of processing power, so lighter weight Raspberry Pi version 3A or B are sufficient, keeping the price down. The V2 camera module almost costs as much as the Pi, good 72p resolution. Do check when purchasing a power supply that it's the correct version. Later models for the Pi now use an upgraded and incompatible version. Finally, the microSD card. This should be 8 gig minimum and described as class 10. Step 2. Fit the camera into the Pi. Obviously, the orientation matters. In a classroom situation, care has to be taken with these delicate connectors, but the good news is that this only has to be done once. Raise the clamping bar using the 2 small protrusions at each end. Ensure that the ribbon cable is inserted well and re-clamp the bar by evenly applying pressure down along the complete length. A light tug should confirm that the ribbon cable is in place. I'm not getting involved in the housing of the camera or the Pi here, as I think some creative designs can evolve. Longer camera ribbon cables are available for those who enjoy the challenge. Step 3. With the hardware ready, the microSD can be inserted, but before this it needs to be flashed with the Telraam software. This involves several interim steps. I assume here that there is provision to insert a microSD card into the machine you are using to view this video. Insert an adapter such as this into a USB port should one not exist. Most modern machines will automatically accommodate and configure such a device. Then insert the microSD card into the adapter. On Windows machines, dismiss this pop-up window offering to format the drive. Next, the latest software, called an image, has to be downloaded from the Telraam site. This is the link that I'll also include in the description below. The download should begin as the link is clicked. It's a compressed zip file which is over 1.2 gig in size and could take some time to download depending upon your link speed. Keep a note as to where this file is being written. This file needs to be written to the SD card. If you've not downloaded the Raspberry Pi Imager, then dispense with any software you may have had to date, as this is the very best that I've seen. Well written, capable and convenient. A joy to use, and it has no commercial hooks. Head to this link to see the download links for Windows, Mac, Ubuntu and even the Pi itself. Select the appropriate download for your machine. Start it once the download has completed. A good clean screen appears, offering the options of the source code to be flashed and the destination of the written file. Although this app has been primarily written to flash Pi images, it may be used for custom sources as well. Click on this Choose OS button to reveal this pull-down option. Use this slider on the right-hand side to select this custom option. Another window appears that allows you to select the Telraam zip file that we just downloaded. This app performs the unzipping as the file is flashed. Select the downloaded zip file. Press the Open option to see the title displayed in the button. Now we need to select the location of your SD card as the destination of the file. So click on Choose Storage to reveal another pull-down. Great care has to be taken at this stage to select the correct option. You could overwrite critical files. One option should match the size of the SD card inserted earlier. Don't proceed if you are unsure. Here I'm selecting my USB option. This right button is enabled once the selection is made, and so, if you're sure, press it. A bar graph displays the process of the writing and verification phases, with the complete button appearing if all has gone well. Step 4. Remove the card and insert it into your Pi. Insert the power supply into your Pi and watch and be patient. The red and green LEDs should flash as the Pi boots and proceeds through an initial configuration phase. Wait for the flashing to cease with just a static red light visible. Step 5. Grab a mobile phone and search for your local Wi-Fi sources. If all has gone well, the Pi has established a Wi-Fi presence, a hotspot that should appear as Telraam in your list of local access points. So select it. The report that an internet connection is not available may appear, but this is usual and can be ignored. Open a browser and enter http://192.168.254.1 into the address bar. This page appears presenting the configuration options and a view from your camera. This control via Wi-Fi is the headless mode mentioned earlier, and why the screen, mouse and keyboard for the Pi are unnecessary. This latest design is done well, really clean and simple. The green bar at the top of the screen confirms an active connection. Below this is the options to switch languages. Next, the image received from the camera itself. There are more details on the Telraam site as to how to best position your camera for optimum performance. At the very base of the page is your serial number that's used to identify your device. Make a note of this. Above the serial number are these two buttons that allow you to switch between the current camera positioning screen and the Wi-Fi connection. Clicking on this second button reveals this screen where the details of your local Wi-Fi can be entered. I do like the comment here about taking care and avoid making errors. Select your local Wi-Fi router in the first box by clicking this option list and then enter the password into the box below. Remember to avoid making errors. Finally, check this tick box to enable images from your computer to be seen on the dashboard that we're about to set up in the next step. Click on this More link to reveal further information regarding the measures taken by the Telraam system to respect privacy considerations. If all is well, scroll down and press this Save and Connect button. Your Pi will attempt to connect to your local router. As your screen says, this may take up to 2 minutes. Otherwise, move forward to the next step. Assuming all is well, the setup of your device is complete. Part 2 involves an introduction to Telraam in the cloud. Head for https://telram.net. On the first occasion, you will need to register for an account. In the top right-hand corner of the screen, select your language, then Register. These are the criteria required for registration, and we can probably tick these off by now. They are not arduous, but should you need to power off and reposition your Pi at this stage, then it is safe to do so at this point. It should remember all of your previous settings. Complete the form. In this space, for network or zone, simply select My Own Telraam unless you are already part of an existing network. Insert and confirm your password and sign away your life by ticking these two checkboxes. Remember to note the details that you have entered and press Register. The job's a good one and you've now completed registration. Step 7. This is your dashboard and your access into your Telraam account, as all of your control options are presented here. And because it's your first visit, a green button also appears to guide you through the setup of your initial node. You can add other devices later as your empire grows. Each stage is presented on this line as you progress. Your position is recorded using this map. This can be a little sluggish, but please bear with it. Click and slide the map around and use these buttons to zoom in and out. Click on your selection of road and then either of the two green cameras that should appear to select which side of the road you are monitoring from. Small A and B markers appear at the end of each section, but if problems occur, each page has these additional help links. Clicking on the selected green camera produces this pop-up with a button confirming and recording your selection. At this stage, you may be invited to reconfirm your now long-forgotten login details. The next step now explains the use of the mobile phone to configure your system, as we performed earlier. This video has been made during October 2021 and includes all of the latest details at the time of publication. This screen explains some of the differences and improvements that have happened over the last few months. These notes here refer to some of the more protracted delays that may occur during the initial setup in earlier versions of the code. Forewarned, progress on to the next step and the registration of your device. Enter the details as supplied and confirm. Now at this stage I've got some good news and some bad news. The good news being that you've probably generated a working system. The bad news is that you'll probably have to wait for up to 48 hours for everything to settle down and produce results. This artificial intelligence lark is not all it's cracked up to be. Ensure your camera location is good and physically well secured. Over time, you will see that the data emerges and this will soon appear in your control panel. It develops with time and we can investigate this and how it's achieved in forthcoming videos. Here we've covered an introduction, the hardware connections, the hardware requirements, how to connect the camera, downloading and flashing the image, carrying out the initial boot process, and using a phone to configure the settings on a headless Pi device. We registered an account and submitted the first details of a sensor to the Telraam system. Now that we know how to control all of these things in the control panel, life should be easier. In the meantime, I'm off for some beef tea, so enjoy looking around.